Stars are among the most diverse and extraordinary objects in the universe. Our galaxy alone contains hundreds of billions of them. From faint red dwarfs, barely visible against the cosmic abyss, to dazzling blue supergiants whose brilliance overwhelms everything around them. Let us embark on a journey to some of the most remarkable stars known to science. We will begin close to home, deep within the blazing corona of the sun, heated to unimaginable temperatures. From there, we will travel hundreds of light years to reach the unpredictable and restless Betelgeuse. After witnessing its violent pulsations, we will continue onward to the dying giant CW Leonis, hidden behind a dense veil of cosmic dust. Then, crossing nearly 10,000 light years, we will arrive at WR 102, the hottest known star in our galaxy. Passing dangerously close to this inferno, we will set our course toward a strange and distant binary system known as MY Camelopardalis. And finally, our journey will lead us almost to the very center of the Milky Way, into the massive stellar cluster Stevenson, where the largest known star was discovered. Prepare yourself. The journey begins. The Sun, a familiar star with hidden extremes. On November 21st, 2021, NASA's Parker Solar Probe approached the Sun closer than any spacecraft in history, just 8.5 million kilometers from its surface. For the first time, a human-made object entered the Sun's corona, the star's outer atmosphere, heated to millions of degrees. Why risk such an extreme mission? What secrets does the Sun hide within its blazing halo? The Sun is a main-sequence star, approximately 4.6 billion years old, classified as a G2V yellow dwarf. Its surface temperature averages about 5,780 Kelvin, though hotter and cooler regions constantly shift across its surface. Deep within, however, temperatures soar to unimaginable levels. The Sun's diameter is about 1.4 million kilometers, 109 times that of Earth, and its mass accounts for nearly 99.9% of all matter in the solar system. Though we often consider the Sun modest, it is actually larger and brighter than about 80% of all stars in the Milky Way. Hydrogen makes up roughly 92% of its volume. Inside the core, hydrogen nuclei fuse into helium, releasing enormous energy. Every second, over 4 million tons of matter are converted directly into radiation. Surrounding the core is the radiative zone, where energy slowly migrates outward as photons are absorbed and re-emitted, a process that can take tens of thousands of years. Beyond it lies the convective zone, where hot plasma rises and cooler material sinks, generating powerful magnetic fields that shape the entire solar system. Above the visible surface, the Sun's atmosphere unfolds in layers: the photosphere, chromosphere, and finally, the corona, a realm of extreme heat, solar flares, and colossal plasma arcs stretching millions of kilometers. The corona's temperature remains one of astrophysics' great mysteries. It is far hotter than the Sun's surface, despite receiving less energy. Parker Solar Probe was designed to solve this puzzle by measuring magnetic waves, solar wind particles, and plasma dynamics at unprecedented proximity. Though its mission will ultimately end in destruction, consumed by the Sun itself, Parker will leave behind priceless data, advancing our understanding of stellar physics and space weather. Betelgeuse, a star on the brink. In late 2019, astronomers noticed something alarming. Betelgeuse, one of the brightest stars in the night sky, dimmed dramatically to just 36% of its usual brightness. Speculation spread rapidly. Was a supernova imminent? By early 2020, Betelgeuse returned to normal brightness. The cause was traced to a massive cloud of dust ejected from the star itself, temporarily blocking its light. Betelgeuse is a red supergiant nearing the end of its life. Its mass is about 17 times that of the Sun, and its diameter could engulf the orbit of Mars if placed at the center of our solar system. Its outer layers are unstable, constantly shedding enormous quantities of gas into surrounding space. Despite its immense brightness, up to 150,000 times that of the Sun, Betelgeuse's surface temperature is relatively cool, giving it a deep red glow. It pulsates irregularly, making precise measurements difficult. Its distance is estimated between 500 and 650 light-years from Earth. Sometime within the next 100,000 years, Betelgeuse will explode as a supernova. When it does, it may briefly shine as brightly as the full moon. Though spectacular, the event poses no threat to Earth. The star is simply too far away. What remains afterward may be a neutron star or even a black hole, depending on its final mass. CW Leonis, the carbon giant, CW Leonis, also known as IRC plus 10,216, lies about 650 light-years from Earth. At its largest, its radius reaches 560 times that of the Sun. Though cooler than most stars, its sheer size makes it over 8,000 times more luminous than our Sun. This red giant is nearing the end of its life. It sheds massive amounts of material each year, forming an enormous carbon-rich nebula around itself. Spectroscopic studies have revealed more than 70 chemical compounds in this cloud, including water, ammonia, and carbon dioxide. The star pulses every 649 days, alternately expanding and contracting as nuclear reactions ignite and fade in its core. These pulsations drive intense mass loss, gradually stripping the star of its outer layers. Within the next 10,000 to 30,000 years, CW Leonis will shed its remaining obolochki and leave behind a white dwarf, a dense, fading stellar ember that will cool for billions of years. WR102, the hottest known tier W. R102 belongs to the rare class of Wolf-Rayet stars, massive hydrogen-poor stars in their final evolutionary stages. Its surface temperature exceeds 210,000 Kelvin, making it the hottest known star in the Milky Way. Despite being smaller than the Sun, WR102 shines nearly 400,000 times brighter. It loses mass at an extraordinary rate due to an intense stellar wind, ejecting Earth's mass worth of material every few months. This phase lasts only a few thousand years, a blink in cosmic time. WR102 is expected to explode as a supernova soon, possibly forming a neutron star. My Camelopardalis, a deadly dance. My Camelopardalis is a massive binary system located 13,000 light-years away. Two enormous O-type stars orbit each other every 28 hours, their atmospheres nearly touching. Each star is tens of times more massive than the Sun, spinning rapidly and emitting intense radiation. Over time, the pair is expected to merge into a single supermassive star, potentially ending its life as a black hole. Such systems offer crucial insights into how the most massive stars form, through mergers rather than solitary collapse. Stephenson 2-18, the largest known star deep within a dense star cluster, lies Stephenson 2-18, possibly the largest star ever discovered. Its radius may exceed 2,000 times that of the Sun. Light would take nearly 8 hours to travel around its equator. Despite its size and brightness, thick cosmic dust hides it from naked eye observation. Its surface temperature is relatively cool, classifying it as a red hypergiant, a star barely stable, shedding mass at a tremendous rate. At any moment, it may explode as a supernova or hypernova, leaving behind a neutron star or black hole. Final thoughts. These stars represent only a tiny fraction of the wonders within our galaxy. Beyond the Milky Way lie countless other galaxies, each filled with their own extraordinary objects. Our journey through the cosmos has only just begun. Until next time.